Right, so I've tried to video this a few times and it just either I've swapped the phone around to a different aspect ratio, i.e. for like Instagram or whatever, but I'm going to smash through this as quickly as I can with as much information as I can. So we're going to fully measure this cylinder head. We've got, let's have a look. We've got valve stem height, valve concentricity, valve seat concentricity, and valve seat height off of the deck surface, so the machine surface. So up here. So we'll show you the valves, we'll show you the height of the seat compared to the deck surface, so you can see if they're even. We'll show you the stem height, which was done from the other side. We're going to do bores and clearances, so on the guides. So basically these little split balls go down inside the guide. They tell you if the guide's tapered or worn, and they're also going to tell you the clearance between the valves. We'll mic up a valve, we'll put a small micrometer in here, we'll mic up a valve and then see the clearance difference. And that, I think, should cover it. Oh, we'll also hopefully talk about seat angles and show you them. This is a turbo cylinder head. Well, I say turbo. It's a standard K20 cylinder head with bronze guides installed and the bronze supertech guides and supertech valves. Stock sizes, it's going to go in my personal K24 in my PS13, so the Nissan. There is zero done to it, i.e. I haven't even smoothed out the transition on the short turn radius on the exhaust. I haven't done anything whatsoever. I will clean them up, but as it was, it needed 2 seats. I think 2 of the exhaust seats, probably these 2, I think, I can't remember. But either way, it's had 2 seats in it, had the valve seats cut. Obviously, we put guides in it. So I don't know whether this one slipped through the net or, I mean, I said I wanted it perfect, so whatever it needed, but nonetheless, when I got it, this was way before I got the Surdy machine to do cylinder heads myself. And to be fair, this is what spurred me on to do the cylinder heads and buy all of these tools. So these tools are extremely expensive. Like in the UK, this ends up being well over £1,000, more like £1,200. I think this, I've actually bought this at PRI in America when I went. I've made this one. This is in America, this is, I think, $350. In the UK, it's like £400 or something like that. It's everything getting here is crazy. This toolkit here, well over £1,000 for all the different sizes. This is in tenths. This is in millimeters. This is in thou, tenths of a thou, millimeters. So there's going to be a bit of swapping between the two. But obviously, if you want to work out the differences, you can do. There's for 0.01 of a millimeter, there's 4 tenths. So down here, bit of focus. One of these little marks is 4 tenths, so 2 is 8 tenths. So you get it. Right, let's start pulling this apart. And the reason I wanted to check the head with all these tools, again, bought all these before I bought the Surdy, is because, let me just show you. Right, so when I got the cylinder head back, I started, looking at it, and what I found was that you can see through some of the valves. And I was like, oh, okay. So I took the cylinder head back, and while I was there, they just cleaned out the guides with some nylon. I'm not sure what else they did as I was standing sort of in the office area. And then they came out, they vacuum tested it in front of me, and everyone pulled vacuum. On their machine, they just turn it on and it pulls vacuum. So it'll pull like 0.7, 0.8. I think it was, probably 0.75 or something. And all of them pulled vacuum, happy days. I didn't even recheck it with the light because they didn't have a light there for me to recheck it. So I took it back. When I got back here, again, I could still see a little bit of light. And I was like, do you know what? I need to buy some tooling to actually check this stuff. Because it's all well and good giving it to a machine shop, but yeah. So let's go through it. Right, so first thing up is the valves and the seats. So let's see if we can zoom in. So you see that seat there and there. So in fact, this is a really good view of it. The seats are the same size. So normally you would have a thicker exhaust seat as that's transferring heat. I've measured these at 1.4 mil with a standard vernier. It could be slightly under, it could be something like 1.35. But just take a note here that you see all these like striations that go round the valve. That's because they've been lapped with some kind of grinding paste. And when I say lapped, it's they've checked the seat, but they haven't got fine enough grinding paste. So it's actually a lap. So lapping paste is going to be, you know, 800, 1,000, 1,200 in that region, where grinding paste is going to be, you know, 400, 600, something like that. And that's what it does. It puts those horrible circular lines in. Now we'll get to that a bit later, but that's not the best. These valves have got a standard back cut in them. But yeah, so the seats are the same. Now, let's just throw them there. See if we can get in here. It'll focus. Or maybe we'll pick this one. So you can see, unfortunately, there's only 3 angles there. You've got a material change below, which looks like another angle, but it's really not. That's the bottom of the seat. Let me see if I can get a pointer. All right. So you can see down here that this is actually the chamber itself. This is the bottom part of the seat, which is just square to the chamber. Then this is your first angle, which I'm not entirely sure what it is. I guess it's a standard 60. Then you've got the 45 seat, and again, because you can see the striations in there. And then you've got a top angle here, which is actually shrouded as well. There's no radius on the cutter that's been used at the top. So there's quite a significant lip. Let me see if I can get a better view on that. So that's quite a significant lip, and you can hear like that's graty versus if I go down here. Let's see if we can do this. Like that's fairly smooth. That's graty, fairly smooth, but obviously they've left a lip. So they've used a 3-angle cutter on the inlet and the same cutter on the exhaust. So I would imagine that the 60 is longer because the seat's smaller. So yeah, we've got the chamber, the port, sorry, here. We've got the bottom of the seat. This is the first angle here. Then again, the really rough seat angle because it's been lapped, and then the top angle. And to be fair, the radius on the exhaust isn't really necessary because there is a bit of a radius there, although there's not. That's quite considerable, that lip. So we've only got a 3-angle seat. Now, for some reason, the generic seat coming out of these seat manufacturers, like the Surdy and other companies, seems to be 30, 45, 60. So 30 at the top, 45 on the seat, and 60 below. In an ideal world, that 60 wouldn't be 60. It would be halfway between 45 and the 90, basically. So 67.5. Assuming you had no angles below that, because that would be halfway between and you're smoothing the transition. There are little things against that, because you do want, like especially on the inlet, you know, anyone that's big into cylinder head flows and, you know, fuel atomization, anyone that's big that's doing cylinder heads, well, when I say anyone, 99% of people are going to leave one angle before the seat, and they might blend the rest of them. So even if you had a 5-angle seat, so Hondas, they have an 86 on the exhaust, and then on the inlet, they have an 80, a 67.5, a 40, and then a top angle of 35 on the inlet and 30 on the exhaust. Now the reason is because the clearance. So the 35 is going to put the valve that much closer to the cylinder wall, which means that it's shrouded more, and therefore the angle is more towards the cylinder wall, where a 30 is a lesser of an angle, and because it's a smaller valve on the exhaust, you've got more clearance. That's the way I see it. Now, obviously, everything is my opinion, but there you go. So you can see that you've got 1, 2, 3, 4, and then you've got an extra one on the exhaust. Now, on the exhaust, they're trying to make that a radius. So on the exhaust, you don't need any angles. Well, again, everyone that's really big is basically saying you don't need any angles on the exhaust below the seat. And that's because it's just a radius. You're not trying to do anything with the gas. You're just trying to get the maximum amount of flow possible. On the inlet, though, you leave one angle. So on the inlet, but they don't even have that angle on there on the inlet because it's not really necessary. But you have the 45, the 67.5, and then you could blend any other angles. It doesn't matter as long as, well, that's what they're saying. As long as the 67.5 is there, because that helps with basically break up away from the wall and helps with airflow. Not reduces airflow, but fuel and air mixture. Basically, it breaks the flow up so it can actually, you know, go into the cylinder head and mixing better. So it's rare to see anyone doing a radius on the inlet. They normally do like a 5 angle and then blend. I suppose you could do a radius, but you'd still want that last angle. So that's valve C. So I've got what looks like 30, 60, 30, 45, 60. I've got the same seat size on both of these. Now this is a turbo, so we're gonna say, okay, it's gonna create a lot more heat. So potentially you might even wanna go 2 mil on the exhaust and maybe keep the inlet like that. Normally you would have a difference. It looks like the same cutter's been used across the whole lot. Let's do a quick show and tell of the valves. Now the valves went with the cylinder head, so I'll just put a few of them in the valve concentricity and we can see what brand new valves are like. Now I have checked another set of supertechs. They are the same, so none of these have been dropped. I took them out of the box. Unfortunately, you'll see. Right, so there's a reason there's an X on this, and this is because this is one of the bad ones. Sorry about that. So you can see here, it's not quite on 0, 1 over or 1 under. Now every time, so just show you, I am putting so little pressure on that, it's crazy, although the cylinder head is rocking in the background. But you can see here that that is at least 0.8 or 0.02 of a millimeter. Right, let's just grab another one. And these are obviously very fine measurements. And with both run out of seat and inlet, there's kind of like a standard that people say and manufacturers of valves say, and that's basically 1 thou per inch, pretty much on all of it. But let's see, so we're now on 5. So this one, we're 0.03, so what's that, 12 tenths? 4, 8, 12, just over 12 I should think. Let's just grab a couple of other exhausts. It's where it finishes up at. So I'm gonna say there's less than, there's probably 4 tenths in that. And if you notice as well that a lot of these valves are all at different heights. So that's interesting. And none of these have been cut or ground. So we're at, maybe 2 tenths, maybe 8 tenths on that one. 4 tenths, I'm gonna say 1/2 thou is fine, and I'm gonna be very happy with that. My machine, which is a sensorless grinding machine, is getting about 4 tenths on average, if I'm slow with it. If I go fast with it, it'll be 1 thou all day long. There is like a little nuance to all of these machines. How you use them makes a big difference. So if you're rushing, yeah, she's not gonna be good. So again, so we've got some that are good. Like I say, 4/10 is very acceptable. Obviously, wow. A thou, well, over a thou really is starting to get borderline. And this is the one with the grinding paste on it, so I don't really like to use this one, just in case. It's only, I think it's hardened steel, that ball. I don't think it's anything too special like tungsten. Could be, I can't remember. Right, let me set it up for the inlets. Okay, so inlets, we're at the 19 mark. So there's, yeah, we're going to call that one 8/10 or 0.02 of a millimeter. This one's got a little seat mark on it, like it's been lapped. You see the difference in the height though? I've not been looking, so. Again, you don't want to look for the jump, because the jump is me literally just pressing. Look, that's just me pressing. It's where it finishes up. It's probably just, you know, 6/10 or something. Like I say, these are exactly the same as the other valves. That's 8/10. But they're not, so, you know, as there's so much difference between these. Out the box, I would say some of these need work. Now, if it's 8/10, I'm probably not going to touch it, because you're going to spend some serious time trying to get that. This is either way out, or this is me messing around with it. Come on, what about if I go the other way? Try and do smaller increments. Nice. This is like, yeah, I mean, it's got to be 8/10 at least. Like I say, I don't want to, because there's a lot to get through. But you can see the difference in the heights, the total height to seat, because this is a fixed unit, so the base is there. None of this stuff is moving enough to. That looks like a fairly good one. Maybe 2/10 on that, or 0.005 of a millimeter. And this looks like it's going to be 8/10. Yeah, give or take. It's probably 6 to 8. And there's not, so I've tried doing it like this as well. It's, I suppose it may be slightly smoother. So we'll just do it like this if it's rotating. Is it rotating? No, I can't. I've lost the ability to rotate it. Oh, there you go. It's very hard to rotate them like this. So what are we getting there? I wish I could watch it and see if it's rotating. So we're probably getting, oh, is that 2/10 or 3/10? Let's have a look. Yeah, you know what I'm saying. Right, let's just do it like this. It's the same, obviously it's just less jumpy. So you've probably got 8/10 there. Last one up. Because I really just try and do it like this. This one's got engineer's blue on it. So I was doing a drop test. So we got, that looks like 6 to 8/10. Oh, no, it might be me there. I'm pushing down quite hard to make it rotate. Obviously it's a small stem. Maybe 8/10, something like that. Obviously, again, I'm looking through the camera so you can see. Right, so this gauge here, basically, let me see if I can show you. So it sits, that marker sits on the seat. This is a straight pilot 5.5 mil, which is actually a little bit loose in these guys, but not crazy. And then basically you sit on the seat and you read the number, so somewhere around there. Let's zero that. Let me just do that, 2 seconds. which at your angle isn't the best, but it's fine. Where's 0? The opposite side. Alright, so this is exhaust seat height, 5.5mm straight pilot, so that's zeroed. And you can see, let me just try and show you it all. So that sits on the seat, that on the head, carbide straight pilot. So we'll just go across, hopefully we won't hit any holes. Obviously you have to be careful with how hard you're coming down, because this stuff can move. And where the, right, so we're, yeah, there we go. So that is 3 under or over. No, 3 over. So 3, that's cut 3. That one's 4 as well. So I heard that push down and hit the seat. We'll go back and just check. So it's still 0. So these are all 4. I think I did this one. I'll just redo it, whatever. No, we didn't do that one. So that's now 5, 6, 7. So I might write these down. The best thing in the world, but when you're cutting seats on the machine, it's actually pretty good. This is not going to work. Let me just see. Oh, maybe it will. Yeah, so this is so tight, this guide. Oh, there you go. No, actually that does just work, and that's, I'll call that 0. So that's fine. Yeah, there we go. That one's minus 3.5. I'm going to round up, minus 4. See, you can see some of them, this pilot goes in really easily, just sinks down to the seat, no problem, where some of them, it's very stiff. So this is minus, oh no, this is, sorry, plus 2. Which just shows that the guides are not all the same size. Last one. Yeah, that one went down okay-ish. And we're back to plus 1. Right, I'm going to do these ones like this because it's just going to be quicker. So yeah, this falls down, hits the seat, no problem at all on every one. So for all intents and purposes, the inlets have a larger guide than the exhaust, which is weird. Normally you have a wider, normally you have a wider guide on the, if anything, you're going to have a bigger clearance on the exhaust. Maybe not a wider guide, the guide should be the same size, but whatever. It should be built into the valve, but if you want to build yourself some extra clearance, you put it in the guide. So I've zeroed that. We are plus 3 from our datum. I'd say all of these, they're just, it should, I haven't checked them, but it should. This is minus 2. So this is style this gauge as well. So this one isn't tense. I'm just going to call that plus 1. It's more like 1.5, but this is only through. Obviously, I'm going to redo everything on this head now. So it's just for the purposes of measuring. That is minus 1. So you can see that this is repeatable as long as the guides actually allow the unit to go in. That's going to be plus 3. And what's your tolerance? I mean, you would want it as close as possible, wouldn't you? It should be affecting valve stem height. This one's a lot. That one's minus 5. Minus 5. I could be doing these numbers around the wrong way, but I don't really want to think about it anymore. As in the pluses and minuses. Appreciate that's well out of your screen, but that's plus 2. Oh, not plus 5. Plus 2. So there you go. So that's going to be valve seat height to deck surface or cylinder mating surface, whatever you want to call it. Shoop. Right, so I put these DTI extenders in there, and I know this one's 40mm, so it's Oh gosh, let me try that again. Let's see if we can get some repeatability with this. So let's just zero it out. And then when I take that 40mm extender out, we should be on point. Oh, let me just check the number. So we're 5, just over 5 at 0. Hopefully this will come out with only one part. Yeah. So now we are 40mm. And anyway, we're not looking for the height as much so when that goes on there, we'll see what the height is versus the 40mm standard. We're going to use the same valve every time because obviously they're slightly different as we've seen. I'll turn that in. So we know that 5 is 40 and we are we're well over that. So we are, let's work this first one out and then we can work the rest out. So we are, I think I've done this before actually. 44.53, I think I measured this out. But we're not now, so whatever. Different valve maybe. So that's gonna be 0. So then we've got another mil, so 41, 42, 43, 44, 44.52. So 44.52, which I've got here, 44.53. Wow. Okay. It's very repeatable. Right, let's have a look. We'll just run through these. Hopefully this is all coming out. I will double check. Yeah, we should be all right, shouldn't we? Yeah. That is way different. So that's interesting. Let's just go back. I want to make sure that we're getting the same. Nothing's changed just between there and there, just in case I'm being a bit special. No, 44.52. Next one. 44.58. 44.58. 44.44, which 44.44. I've measured these before, so 44.5, well 44.6 really. 44.54. Hopefully it's still coming out. Might need to move you back a touch. See how we go on this one. We've only got 2 more to do after this. 44.54. 44.55. 44. Yeah, 55. 40. Oh my gosh, what was it? 44.5. Might have been slightly over. Either way, 44.4 is that? 4444. That's all the 4s. So we've got a range from basically 4444 millimeters to 4461. So let me just work that in. 2 seconds. Right, I'm going to swap over to the inlets. And we'll get this. Oh, is that the inlet? Yes. This might be a little bit slower because I can't see. I could turn the head, but can't be bothered. So a minute, is that even more? Shoot. 1, 2, 3, 4. Oh no, same, yeah. 4455, which is what I measured before. 4458, 4456. Sorry, 44558. Should be less this one. Yeah. 445. So on the exhaust side, as I'm doing these, well, that one's a bit higher. 6.2, yeah, 4462 is what I got previously. So that one's 4438. And there's going to be a little discrepancy on all of this stuff. I'm never going to get within the same thou every time you measure it, or even I would imagine a couple of thou, but it's consistency between them. Yeah, so that's for whatever. So the exhaust side, that was 6 thou variation between all of them, basically. The deepest and the highest, 6 thou variation. I think almost the same on this side, maybe slightly less. 1571, 1574. See if we can get on the edge there. It's really not the best tool. 1560. But if we go by that, 1560. These all look pretty good. No, 1570. 1560. These all look pretty good actually. Obviously this isn't the correct tool to use. 1570. It's going to get you ballpark though. 1560. 15. I'm going to say these are all basically the same. 1570. And that one looks like it's quite in there. 1550. Yeah, I mean they're all within. I'll just quickly show you. So you can see they've got that little bit of clearance at the very bottom down there. Just in case we were looking at different things. Yeah, so clearance down at the bottom there, you can see that, whatever that is, like a mil maybe. So we just run past them all. See, that one seems like it's out a little bit more than the one next to it. You see that? They're all similar. Yeah, there's just a couple that look a little low versus a little high. We'll just have a quick look at these ones. Like I say, they measure up fairly close. And they all look pretty good. They look better than the inlets, that's for sure. Right, so now we'll probably do guide clearance. So I'm gonna keep this all in inches. So imperial, we're just gonna close up on this inlet valve. That's fine, I'll lock that off. Or not lock it off at all. Not put any pressure on that, doesn't seem to be moving. Right, so that measured out at, oh gosh, 215, 215, not massively fast at inches. Ooh, 215, 215, 215 what? 215. 2157. Just going to convert that quickly and make sure that I'm reading that correctly, but it looks correct. Okay, yeah, so I've done that on the metric as well, and it works out basically both of these mics are within 0.2. So with this I got 5.475 roughly, and with this I got 5157, so within 0.2 of each other, so that's pretty good. I'll set up the bore gauge and then we can run through the inlets. So to set this up, I'm basically going to stick this split ball in this gap. I've already got the right size, and zero it. But yeah, so that we're calling that basically 0. So that's definitely going to be within 1/10. So now we'll run through the inlets. Okay, so we are going to stick this down inside the guide. Oh gosh. and check where 0 is. So, oh, actually, so there's 0, and then we are, so that's the actual 0 mark, what we did on the guide, which ended up at 02157, and there we are at basically 1.5 thou. Oh, just bear with me, let me get me settled in. 1.5 thou. Oh, nice. Yeah, I mean, a good 1.5 thou. Lovely. Let's have a look. So 1.5. Let's just make sure she's not coming out the bottom. There's a little, she's not out the bottom yet, so there's 2 at the very top. Or very top. And she goes up to just over 1.5. Hopefully this is coming out all right. Should be. So now we're at considerable amount more. Let me just double check that, make sure nothing's come loose. No, we are the same. So this one apparently is 2.5 thou, and increasing a little bit back down to 2. Just some discrepancy there. Right at the top, let's just double check the very top. You have to be careful there. So, yeah, so we are falling out, but it is expanding right at the top, but that's fine. The split ball is currently at that angle, if that's too, yeah, it's like at 45 basically. So there you go, there's that 1.5, there's 2, coming up 2. That's really, so that's like 1, 2.5 at the top, and I've not come out the bottom of the guide. The guide actually finishes, no, I'm still in the guide. So the guide finishes here. So what's that, 1, 2, 3. So 3 right at the top, and then you can see that drops out the, yeah, drops out the guide there. But 1.5 is the consistency there, or the constant. This one's all right, a little bit tighter, and then again, I'm not out the guide there. So I'm about to fall out the guide around that 55 mark. If that's still in the camera, only just. So yeah, right at the end there it is 1, 2.5, but most of the way, this orientation, we got a little bit, oh, that's me, sorry. Yeah, no, we're 1.5 nicely. I don't know if I did this one or not, I might have, but so we're 1.5, and then we're falling out the bottom right there when we get the huge increase. This is coming up. You know, we're pretty good. We're a little bit tighter in the middle there. But these guides don't look like they've been honed, they look like they've just been a reamer run through them. Yeah, so 1.5, and then obviously falls out the bottom of the guide. I could check the bottoms a little bit better, but having already done this, yeah, I mean, I'm still not out. I'm just falling out there around that 55. Yeah, you can see that big jump there. That's basically, no, it's not. Yeah, I'm coming out the guide at about 55 there, so 1, 2.5. This one's a little bit bigger anyway, so it's giving me a 2 thou clearance. Right, see if we can do this at 90 degrees. So this direction, I'm gonna have to lift up over this. We are at 2, and pretty much, oh, sorry, was that 2? No, that's 1.5, sorry. Yeah, so pretty good. This one, 1.5, nice. Oh, that's me, sorry. Pretty nice. And here we go. Oh. And this was that large one on the other side as well, wasn't it? So yeah, this is at 1, 2, 2.5, this guide, for some unknown reason to man. 1, 2, it's 2.5. Oh, and then she goes tight again. I mean, she opens up right in the middle there. 1, 2, nearly 3 there. That's actually pretty much slap bang in the middle, and then tightens back up and then opens up when she falls out. So that one's really, really loose. We still in frame? Yeah. So right at the top, right up here we are 1.5-ish. There's 2-ish nearly. Yeah, she's pretty sound. Yeah, 1.5. We still in frame? Just. So we're actually more like 1.5, bit tight, 1. I mean, these are all over the shop anyway. They're not straight, these guides. They feel very unstraight. Yeah, opening up to like 2 there at near the bottom. These do flare out at the bottom and the top. Right at the top, yeah, nice. 1.5. It's still not out because I've got my nail going across that, and obviously my nail is arched or has like a crest to it. So we are. I mean, out is interesting. Yeah, so all the way down, this only just comes out. But there's they're literally like tapered at the bottom. And then yeah, 75. Yeah, so there's 1.5 thou. Oh gosh. Yeah, so that one's really bad. I mean, that's yeah, so that's not at the bottom of the guide yet. That's actually the bottom of the guide is probably, let's do it like that. That's the bottom of the guide there. So actually, so I'm putting my nail basically up into the center of the guide, and the nail's obviously, you know, curved. Because I don't have ZL manicures. So we are at like, what's that, 1, 2, at least 2.5 there, is that? Yeah. Okay, so here we go again. Oh, we're already at 1.5 there. Oh no, we're already at 2. So this one's already at 2, and we tighten up a little bit, and sure enough, loosening up. But yeah, mainly that's 2. So that's a fair bit of clearance, with some obviously being a lot more. Exhaust. So here, I'm not going to zoom right in, but I've got an exhaust at 0.2146. I am going to do this on the other mic, in my hands. It's not the best, but and that is coming out at, and I will work out the difference, that is coming out at 5.4, 5.45, maybe 4. I mean, it's you know, pretty hard. Maybe a 4 or maybe a 5, depending on the parallax, sort of, if that's the right word, the angle you're looking at it. So here are the numbers here. Inlet exhaust 2146, 5.454. That is within 1/10 between these two numbers. So we're within 1/10. That is ridiculously close. So we can say that that's accurate. Now we'll run through the guides. Right, so this is that zeroed in that caliper mic. So we are, I mean, if you're trying to be really silly accurate, almost 1.5. And we're going to shoot down. We've just gone up quite a bit. Yeah, so this doesn't come out the bottom of the exhaust guides whatsoever. In fact, I can put my nail in the bottom of the guide and I do not touch this. I don't know how far away that is. It's got to be, oh gosh, that's like 4 mil, at least 4 mil away from the bottom of the guide. So I don't need to worry. We can just run through them. The only thing I need to worry about is it popping out the top. So we basically got 1.5 thou. I think that was. We're at 1.5. Oh, yeah. So, and like I say, we're 4 mil from the bottom. We are 1.5, and then suddenly, oh, we get, that's 3, then 4, then 5. Yeah, I mean, that's 6 now. There's a few areas there. I mean, what's that? There's 8 in a thing, so that's 7. So you can see that there is a problem on that one. So again, we've got, oh, that's less than half a thou. So, sorry, just over half a thou, which is a bit on the tight side now. Yeah, I mean, like, what's that, 8? Ooh, 8/10. That's because I started, basically if you lean on it to one side, obviously you hit the shaft. But yeah, we're less than a thou on that exhaust one. A thou, and then we're at, yeah, I mean, you can see it just like I can. It's 1.5, and then back down to 1, and then back down to 8/10, which is interesting. So yeah, we're at that. There's 1.5. Right at the bottom, we're at 2. Like I say, it's 4 mil from the bottom, so we're nowhere near coming out. Don't think I've measured the tops of these properly. So we're at thou. So top of the guide, we're at 4/10. Then there's a thou, and then there's down a bit. Last one. So there's half a thou clearance all the way through. Right, so we've got a thou at the bottom, and we'll creep up, excuse my head, and we end up down at half a thou, which is crazy. Start at the bottom again. Half a thou, or maybe a thou. Yeah. Oh. So for some reason we've got tighter exhaust clearances than we have inlet. I mean, we're at 5/10 there. Let's check again. Oh, we're just about to pop out. Probably nothing, that one. Okay, this is interesting. Just check. Was this the big one before? I'm just going to go back in and check this other one, make sure something hasn't happened. Nope, we're fine. You just got to question yourself. So we're at, right down at the bottom there, we're at what? 1, 2.5. And then we tighten right up to 1.5. Oh, down to 1. And top of the guide's there, so we're about 8/10. I mean, how weird is this? There's a thou, slightly more, coming up to 1.5 thou, which is nice. Reducing back down to a thou. Right, so we are just over half a thou. Coming up, yep, so a thou. It's just really odd that you would have, well, you just wouldn't have larger clearances on the inlet than the exhaust. So yeah, what's that? 1, 2, it's 1.5, 1.75. There's 2. And they feel a bit rough. So yeah, and then down to 1 at the top. And what I'm just going to do, just to make sure that we're, oh, that's probably the wrong size one there to do that with, but this feels really rough coming through there. Oh, that's me leaning on it, sorry. Just because I was trying to feel how rough it is. Yeah, it's the same numbers. It just feels really bindy and rough inside. And then the last one, 1.5, Oh, coming up to 2-ish. Then back down. So there you go. Yeah, so we've got some weird sizes on the guides. They don't look like they've been honed, like when you put a light underneath them, they just look like they've been ringed. They don't look like they've got cross hatch in them, which would be the honing process for diamonds. So now obviously I've gone out and bought myself all of that equipment. So I've got the diamond hones to make sure basically it's true and it's actually got a cross hatch surface area inside. Right, so now we are going to do valve runout. So previously I've done it with in fact I might just grab one and show you. Right, so here we have a tapered pilot, which is generally what is used with a runout gauge. The taper pilot is a very fine taper. In fact, I could probably tell you that's a thou between basically half that length, which is probably 30 mil or maybe just over an inch. So they're quite a slow taper, but and as I see it, you've obviously got the valve, and if there's any tulip at the top, we're going to call it that, then this is obviously just going to follow that tulip. So let's just have a quick look. Put this down in here. It might be too small, this one. I've got to set up for the exhausts. Or is it set up for the exhaust? Wouldn't that be nice? We're saying that's 0 roughly, and we are at, what's that, 9, nearly 10 tenths, 10 tenths, nearly 10 thousandths of run out. Now, this is a tapered pilot, and with these guides, the way they are, this is just sitting pissed in the guide. That is not 11 or 10 thousandths out. Now, it's tapered, and I do not believe, and I know everyone uses the tapered pilots, I do not believe this is giving me, especially with how bad these guides are, the most accurate representation. Whereas a straight pilot is going to basically simulate the valve itself, and as you can see, this is a 5.5 mil, and these pilots from Surdy come in 0.01 millimeter increments, so we're talking about 4/10 increments. Now that's pretty stiff in there, like yeah, I can't move, there we go. So it's really quite stiff, it's not going anywhere. So if we now come in, so that's why the guide goes, the valve goes through, because it's obviously undersized because the clearance is in the guide. And we can pretty much fit this anywhere because we can set the height. So the clearance is built into the valve and not into the guide. So this is why the 5.5 mil guide goes through, because it should be a 5.5 mil. Right. So there we go. So previously I've got 7.5 and I've now got 7. So I'm within 5/10 of my previous readings. Now, for some reason, if I turn this, yeah, I should be able to do it just like that. The numbers might change where they are. So now I'm at 1 basically. Let's just give that a go. Hopefully you can see that. Hopefully, maybe we'll zoom in. Now we're at 5, 6, oh, so they're the same. Sometimes when you turn it 90 degrees, I don't know whether it's, I don't know. Sometimes when you turn it 90 degrees, you can gain a few tenths here or there. So move that back. Are we still in focus? Yes, we are. Let's zoom right in so you can see that. So this particular seat, is, yeah, so there is a few tenths in it if I rotate it for whatever reason. Just tolerances. Tenths of a thou are obviously extremely ridiculously over the top, but we are at 7 thousandths of an inch. So I won't remark that one. I can do a few more. This one is just under 3. 2. We are, oh no, we're going over this side. So yeah, 2.2, 2.3 a jump. So previously I've got around 7 tenths on this. Oh. So now we are under 5. So, I mean, the repeatability of it, I think if you're going to say you're within 5 tenths on a bad day and probably 2 or 3 tenths on a good day, some of these numbers are rounded up anyway, which I shouldn't do, but you know, sitting screen is fine. So this one was 3.5. So now we're probably about 3, aren't we? We're more like 1 now, and that could be where I'm a different position on the seat. So you imagine I've got the physical 45. I could be anywhere on that seat. Depending on the circumference size, you're going to increase the run out. And that's why there's like this industry standard of like 1 thou per inch. And these are 30mm valves, which are obviously just over an inch. Well, a few, 3-4 mil over. Give it a go. So I'm now getting 4. And it's now 1. Or maybe... they're so stiff to turn. Yes, we're now 1, so we're a couple of tenths out. Inlets, I don't think there's a single one that I can do because they all just want to fall off the face of the earth because they're bigger than the exhaust. That one was... we could try doing that one. Right, I'll put that on the centre of the seat. It's a bit too difficult to get an accurate reading, but that is going to be 2 thou or 2.5 thou roughly. Like I say, these are too loose to do with the straight pilot, and unfortunately the guides are too messed up, i.e. tapers and things, to be doing that. Dooby. Yeah, I mean, you can't take any of them numbers on face value. You can obviously use a tapered pilot, so I'll just quickly run through that. Do the last little bit. Call that 2. Okay, excellent. Well, maybe not excellent, but we finished that part. Okay, pilot's away. Woohoo! Right, so last thing is just this one that's crazy out of spec, the 7.5 thou Runout. Obviously, I don't think that was the one with all the taper on it, or was it this one? Either way, let's just do a quick spin around and show you the light coming through the port again. Right, always turn the light on, which is less helpful because we want to show you the light coming through the valve. So you can see and it's not closing on the furthest side away, it's actually just open. It's just the way the light's bouncing off everything. You can see that valve is not, I mean, I have to, sorry, ignore me opening the other one, but even if I pull that considerably at this point, there is still some light coming through. Let me try and turn this torch off the camera, but right, so I appreciate you can't see much there, but that is without the torch on. You can see that that's coming through there. Let me just try and grab it. So that is not really doing much on that side there. It's touching on the opposite side because obviously that huge amount of run out. Okay, yeah, so this is the offending seat, and you can see it's clean apart from this bit here, which is where I was checking the where the gauge was for the concentricity. What I'm going to do is I'm going to mark that 45 up completely with pen, and then we'll do a gentle valve in rotate. So while we're letting that dry, let's just discuss this lapping paste issue, which is not lapping paste, it's actually grinding paste. Oh, there you are. You know, no noise basically, lots of noise. Now, okay, so my little theory here, you've got your 45s, these are the two 45s, this is the seat, this is the throat, this is your valve, this is your 45s on your valves. As this comes down, God, I wish you'd stop focusing on that, my finger. As this comes down, it's going to sit on that surface, and assuming they're both 45 exactly, they're going to meet. Now, with expansion, the valve's going to be hotter than the seat, well, most likely, but 40% of the heat of the valve comes out of the into the guide, and obviously the rest has got to go somewhere, so I'd imagine a big chunk of the rest of the 60% goes through the seat. Now the seat's in an alley head, so that's absorbing heat really quickly, water travelling through it. So as this expands, as they're both the same temperature, when we machine them, doesn't matter really too much if this expands. Now potentially you could say, well, this tip's going to expand slightly more than the body, so you could get some sort of bend. Okay, fair enough. There are some caveats to that, but let's just say that the valve is heating up as one uniform unit and that 45 isn't changing. So that's going to meet up with that. Now, if this grows, it's still going to be 45, but it might sit slightly higher in the seat. So we might go from, we might be sitting perfectly here, but we might move up slightly with expansion of this valve, because obviously it's taper fit, so that if it's larger, it's going to shift up slightly. Now, perfectly machined surfaces, which, you know, that's a caveat in its own right, because, you know, nothing's going to be perfectly flat. It's always going to be a percent, like, you know, look at profilometers, look them up and you'll see. But then that grind I can feel with my finger. So then you've got this process, and you've got a bunch of peaks and valleys that have got to line up. Now, when you're grinding that valve in, sure enough, those peaks and valleys, they're going to sit in each other, and they're going to take up a clearance because you had bits of grit in here. So it wouldn't be perfect, but you'd still have, you know, when you were grinding that in there with your 400 or whatever, maybe you're lucky and got some 600, you're going to have this obviously zoomed in. Now what happens when it expands? So then you could potentially have the point where actually all the points line up, and then you've just got a load of hot points running through because it's not transferring the heat as well as it could because of the contact. So you could really get some serious valve, you know, temperature in the surface. I mean, you could also say if it's losing 40% of its heat via surface area, you have certainly increased that. But we know that's not the truth. So yeah, I mean, just that's what I always think when I see lapping in valves or grinding in valves. And like I say, I'm sorry, 400 grit. I mean, you can see whatever lapping paste this has had on it. Let's see if I can see. I mean, you're telling me you can't see that? So yes, it marks up the seat, but it also leaves, I mean, something I can physically feel that. And if I can feel that, that's got to be some serious roughness. Feel it with my nail. So yeah, I mean, that is my thought. That makes more sense to me, to have a perfectly smooth surface. And then, like I say, if you do lap it, it's crazy. Like you'll see like this top machine surface up here where there's no lap, you can still see striations in there, but that might be their tooling. But that bottom one's really quite nice. And that is so smooth. You can the difference is astronomical. But then, yeah, I mean, that is to me the way. And then when you lap, that's what I was going to say, when you lap, it honestly, you can see, I mean, you think that there's no chatter or anything in this perfect one. I mean, I can actually see a little bit, but it is astronomical how the lapping compound of 1200 shows up the striations, like and they're always downwards, so they're obviously it's chatter, so it's rotational, so they're facing this way. But yeah, really shows up quite well. I will get round to doing that part. Right, so they are now dry. I'm going to do it from the back side. So as you can see, this is one of the valves that's got a little bit of run out on it. I could use another valve, but I can't be bothered. So I'm just going to pop that in there, and then I'm just going to, the only problem with this pen is it's actually quite grippy. So hopefully we'll see some. So you can see there, that has come up perfectly pretty much. We have got, oh boy. Let's see if we can't do a better job than that. So you can see we've got a nice seat, concentric seat all the way around. Yes, not all the paint has come off in like there, it's still on there a little bit. I mean, this seat has got run out in it anyway, and who knows actually how good it is. But we've got no margin. So that seat is actually right on the very outside. So normally the aim is probably to put it more in the middle of the complete width. Let me just clean up a bit of the width for you. So I've just cleaned up the entire width there, and you can see that seat is actually right on the outer edge. There is no additional, so this is the margin here, and there's no additional extra sort of margin on the seat. So it's right on the very outside. Which is not the end of the world, but most people and most industries, like, yeah, performance stuff, most of the people put the seat, you know, in the middle or slightly to the outside, but never right on the very edge. So that's been done there. Again, that's not really detrimental in any way, but let me just lift you out and show you. All right, hopefully this is fairly obvious fairly quickly, but we have a seat that, or the paint, or the pen that has been removed here, and it has a full seat up into sort of here, and then it's not touching at all, and then it has a full seat from here all the way around. Now let me paint this up again, and I'm going to hit it with some 400 grit. Right, so I've got some acetone, which is going to get rid of the pen marks, which is obviously the seat that we've just done. Let's just clean that up, because we don't want any marks in there whatsoever, because this is how we're going to rely on the pen going in again and giving us a true mark. Right, so if you could focus, you fuck. Oh, let's give it a go. Any sign? There we go. Right, so no pen, this is a 7.5 one. I'm going to pen that up, and I'll pen the valve up again. And we'll do this without coming out, just to prove the point. Twice. So I've found some fine. Are you fine? I'm fine. So that should be 600-ish, something in that region, and I've got 1200, which is actually lapping compound, not grinding paste. because no one's got time to wait for that. Right, so that's dry. You can see it's not coming off. Maybe you can see because this camera is dog shit on this new iPhone. So that's not coming off. We're not getting rid of that. Not by gently wiping. I'm going to put a small amount of grinding paste on here. So again, see if we can go. So you can see the grinding paste on there. Oh, there we go. Let's just stick this on here if we can. Oh gosh, that is disgusting. There we go. So all that grinding paste has now really just been pushed out of the valve face itself and is actually just rounding off the edges of the valve, or where the valve seat sits. So I think that'll probably do because it sounds fucking terrible. And sure enough, we have a perfect seat all the way around. She is looking glorious. Shows that, well, because it's much wider than the physical, well, oh, are we going to do it? Let's try to. It's where the grit has come out, it's actually making the seat wider than it should be. I could check that. I can't be bothered, but yeah, it's definitely wider than the seat actually is. So now we'll just clean up. We'll put this to one side. Yeah. So now we saw what he did with the pen. Oh wow. Okay. I want to try and do this without. Here we go. Full seat. So just to show you 7.5 in there. Full seat. Because the grinding paste takes up any clearance that is in there. Right, so we're going to do the whole thing again with lapping paste. 2x zoom. So you can almost see the individual grains on this other thing where that is, well, it's lapping compound. Again, that's not going anywhere, it's dried. Let's get a bit of lapping paste, take it out of the lid, because why not? This stuff goes on more like water, so it's a bit harder to try and manage on the valve, but I will show you how much I'm putting on. Let's have a look. So there we go. Again, not putting on too much. So the seat and the guide, seat and the valve have been drooping. Oh gosh, she's dancing. And you can already hear. And if I just, you can hear, well, hopefully you can hear that. But if I just put in a normal valve, let me just finish this. I mean, if you probably hear the dehumidifier in here more than you can hear this. Let me just spin this one though to give you an idea of the, if you can. I mean, this sounds softer than that, where the other one sounded like it was ripping a new one. Again, the seat is going to be slightly wider than what it's saying it is, and it's left a much. It's left a much nicer finish. Hopefully we can see that it's actually getting rid of the striations, or whatever you want to call them, the radial rings. I don't know what the right word is, but it's actually getting rid of them and smoothing it off, almost like a polished look. And let's just have a little look and see what the oh. Okay, well, I've not done this before, so it was new to me as well as you. Well, maybe you, or maybe you know what you're doing. Right, it's obviously zoomed right in. So you can see the seat, and you can actually see it's actually cleaning up the seat, but you can see, I didn't think it would, but it has, where it's such a light lap, and I did that for quite a bit and pushed quite hard. But yeah, it's basically missed this back section. And let's just get the old poker. So let's just see if you can see the difference. Oh, that one's not the, I don't think we're, I don't know if it's, is it just going to do my finger? Yeah, I mean, you can't hear that now. So it's got rid of the, so it's already got rid of most of the damage that's in the, you know, the striations, and it's shown a decent seat most of the way around. But if you just do it with marker, we know that it stopped there and stopped there. Right, so there you go, straight all the way through that cylinder head. And let's clean some of this up. I don't know if there's anything else I could measure or check that would really have any relevance. You can see the difference between lapping paste and grinding paste, regardless of what they actually call this stuff. I don't know if the phone is falling, but that is the fine. I've got the course somewhere. This stuff should never really be near engines, and you can see the, you know, the noise difference and the striations, or whatever you want to call them, and then versus this one. This valve is obviously the worst one we've got, which is 7.5 thou straight pilot. But overall, obviously that's the problems with the cylinder head and all the issues, and the reason why I've gone out and spent a fortune on a Surdy machine and a new valve refacer and all the tooling to go with it, because we want to check all of this stuff, because this machine shop does nice work pretty much all the time. It's that's just rubbish on there. So whether this one just slipped through the cracks, I don't know, but I said I wanted it perfect, and it's certainly absolutely nowhere near that. The heartbreaking point is that it's got brand new guides in it, which are now ruined. The seats, he's replaced 2, I think, of the seats. Realistically, the seats are too low now anyway. So I've got to pull all the seats out, which is fine. I'm going to put exotic materials in this. I'm going to go for a nickel copper, or a copper nickel. It's similar to like the berylliums, you know, the copper berylliums, but this particular material actually outperforms the copper beryllium in all aspects, basically. But so we're going to make some seats up for the inlets and the exhaust. I'll probably keep the valves and try and improve them. I've gone over to GSC. Well, actually, I'm probably not going to keep these valves. I might put them in something else at some point. There's nothing wrong with the valves, they just need a touch up on the refacer. But I'm going to go over to GSC valves, GSC power division valves, and guides. The guides do have stoppers on them, which I thought was a really cool idea, because I've not seen it before. And then I realised that if they hold them out too much, maybe if I put big cams in it, we might have some clearance issues. I haven't looked at them yet. So yeah, there you go. That is the Honda head that I've spent a fortune on. As I say, guides, whatever they are, valves. I think we're in the region of like 450 quid for parts, and there's 600 quid's worth of work done. So replace 2 guides, cut all seats, replace 2 seats, replace all guides, size everything, and skim the surface. So there's 70 quid or 80 quid in the skim, but obviously I'll probably have to take another thou off this by the time we actually get there. Not that I've got a knee mill yet, but that can just go back to the, you know, anyone. So yeah, there we go. That is the Honda cylinder head that I have paid close to £1,100 to have done, and I wouldn't want to run this. So one of the aspects that you need to think about is, in the UK, people, you know, there's comments about, supertech guides, losing the heads and things like that. But if the work is like this, then that's no wonder, because every time that valve comes down that seat, it wants to shift. Now, fortunately, I say fortunately, flipping it, the inlets are bigger than the exhaust, but the clearance in the guides, probably not on this exhaust, can take up some of that play. Obviously not going to take up 7.5 thou, so that head is going to come off, especially with all the heat and everything. That head is eventually just going to rock backwards and forwards as it slams down on that seat and wants to seal that way, because you can see it's not touching. Head's going to fall off the valve probably in no time at all, and then you've got a destroyed engine. So we are going to improve this a lot. I am getting on my machine currently, obviously if you see my videos, I'm getting less than a thou run out, depending on the guide and the seat condition. I haven't done a single set of new guides yet. I've only done old guides, and on that LS, which is a 40 mil exhaust valve, I'm getting 4/5 6/10. On the inlets, which are a 2-inch valve, I'm getting nearly a thou, maybe 1.2, depending on which hole I'm in. Now, I think a lot of that is to do with the guides. Once we put new guides in it, this or the LS head, which I'll obviously video anyway, but once we put new guides in the LS, whether I get steel or manganese bronze, I don't know. I probably want to get manganese because I want to, focus on that sort of stuff. And it's got to have new seats anyway, because all the seats have been cut too deep. I thought I might be able to get away with it, but I haven't. So once we get that way, then I can make this guide extremely tight to this. So basically you could check your run out, and I could get one under. Oh, I could get one over, I suppose. So we go to the right size pilot, so there's a bit of clearance in there. Well, not that, but so this pilot is the pilot you'd use to do these, because this is 5.5, but obviously in the inlets, yeah, you'd want that sort of clearance, which is basically 0. And then on the inlets are probably should have cut really nicely. I know there were 1 or 2 are a little out, but of course 1 or 2 were also a bit loose, weren't they? I think that one, yeah. So that one's, I can wiggle that in there. So that is definitely, it's surprising a few tenths, and obviously the distance it is. So they'll all be cut to a very tight tolerance. I'll probably put anti-seize on these when it's running in the machine, and then we can have hopefully even better than a thou per, well, definitely better than a thou per inch, but if I can get half a thou per inch, I'm going to be super happy. I mean, it is what it is at the end of the day, but it certainly isn't this. Do you know what I mean? Like 5.2, and it could be because his machine isn't as stout as the machine that I'm running or other people might be running, and it's just where it's sitting on a hardened seat. It's getting pushed around because they're a single point cutter. Again, if you've seen the other videos. And these, well, I don't know what Honda seats are made of, but if they're powdered metal or sintered, whatever you want to call them, they go from like a rock wool hardness of new to 25 or something like that, and then once they're hardened, work hardened, they could be at 40, 45 or something in those regions, I'm sure I read. So that makes a big difference, because a single point cutter can obviously deflect quite a bit. But there you go. So that's pretty much everything on that cylinder head and how it is not any good for my use.